Hello everyone, in this video we are going to see the serial communication interface of 8051. So 8050 inside 8051 you are having interface, or you are having the necessary registers and the control logic for serial communication. Okay, so in serial communication you are transferring one bit at a time, bit by bit, and unlike the parallel communication. In parallel communication, a word, a 8-bit word or a 16-bit word may be transferred simultaneously. All the bits will be done simultaneously. But in serial communication, you are using bit by bit. There are many scenarios where you are using the serial communication. Okay, so now there are two pins of port 3. Okay, port 3 of 8051 is having a special functions for every pin, and pin number 0 and pin number 1 of port 3 of 8051 is called as TXT, transmit data and receive data pins for the serial communication. Okay, and one more thing about the serial communication is you have to define a baud rate. That is, you have to transmit in a particular rate, and that rate is called as baud rate. How many bits are transferred at a time in a second, sorry, in a second, is called as the baud rate. Okay, so this baud rate, there are some standards. So 9600 is a standard baud rate. Okay, 4800 is a standard baud rate, and so on. So we have to create this particular frequency also from the available frequency. So how it is done is, you're having a 11 megahertz crystal frequency, and internally it is divided by 12. So everyone knows that internally 8051 divides the crystal oscillator frequency by 12. Okay, so suppose if you're having 11 megahertz as the crystal frequency, you will get 921.6 kilohertz after the internal division by 12. Okay, and there is a UART, universal asynchronous transmitter receiver. This will divide it by 32, and you will be getting an output of 28.8 kilohertz. Okay, so this frequency is available now, and it will be given to the timers of 8051 to generate the required baud rate. Okay, so now if I am having what is it, 28,800 hertz coming. Okay, if I want 9,600, we will be getting it by dividing it by 3. Okay, if we want 2400, we can get it by dividing it by 12. Similarly, 24 as the divisor will give you 1200. Okay, so in order to get these things, you can use a timer, and this timer will be loaded with the value which will be creating for this case. It will be creating creating a frequency when it is counting once in 3 times. Okay, and once in 12 times, and so on. So -3 is the count. Otherwise, from FD it has to count up to FF. Okay, so FD, FE, FF, it will create one count. Okay, again FD is loaded again. Okay, timer, what is it, auto reload mode, it will be again loaded again. It after 3 clock pulses of 3 clock pulses, it will produce another clock signal, and so on. So it will be producing 9600, uh, 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 a frequency of 9600, which will be used as a baud rate. Okay, so we can you can create 9600 or 2400 or whatever we require by giving these as the divisor values, and these divisor values are loaded as the count values in the timer, and these are the count values. So for -3, that is for dividing by 3, you have to put FD. For 12, it is F4. So you can get it by finding out the 2's complement of these numbers. Okay, so FD will give you, what is it, this clock frequency divided by 3, which is equal to 9600, and so on, so on. Okay, so you will be using the internal timer to produce the required clock frequency, and there are two registers. Okay, two pins we have told. Okay, and then baud rate I have told, and there are two registers which are used for serial communication. One is SBUF register, serial buffer register, which is a 8-bit register, which will be having the data to be transmitted or the data which is received for both ways. Okay, while transmission and also for receiving, this SBUF is used. Okay, so it is a 8-bit register which will be storing the data which is transmitted or received. And then Okay, how will you access the yes buffer register? So these are some instructions which are accessing the yes buffer. So move yes buff comma, okay, within quotes if I give D, that will load the ASCII value of D. So D's ASCII value is 44H and this value will be loaded into yes buff. So you will be able to transmit string values also, okay. And you can also access this, you can give a immediate data here, and in the second instruction you can have data transfer between SBUF and accumulator. Similarly SBUF and accumulator, okay. So this is how you will access the SBUF register. And then there is one more register which is the serial control register. So the serial control register is a 8-bit register and it is used to program the start bit, stop bit, and data bits for the data frame. So already I told you that this in serial communication there will be a start bit, okay, a stop bit, and the 8 bits in between. So minimum 10 bits will be there in one frame, okay. One byte of data will be packed as a 10 bits and which is called as a data frame, okay. So and this is determined by the mode, okay. So there are 3 bits for mode, okay. SM0, SM1 and SM2 are the mode bits. SM2 is for multiprocessor, okay, and this combination will give you 4 modes. And then REN is receiver enable, okay. To for enabling this in serial communication, this will be 1 for both receiving and transmitting. And then TB8 is the transmitter bit 8, okay. And then this is receiver bit 8, and then this is transmit interrupt signal, transmitter interrupt signal, and receiver interrupt signal. So this TI is transmit interrupt flag. It will be set by the hardware or 8051 once the transmission is over. That is when the stop bit is transmitted, this flag will be 1, indicating that one transmission is over, one frame is transmitted. Similarly, one frame is received, this receive interrupt flag will be set, okay. It will be set by the hardware and it can be cleared by the software. Software means by writing a instruction, by writing a program you can clear this, okay. So SBUF register and SCON registers are the two registers used for serial communication, okay. And now modes, these two bits, the mode 0, mode 1, mode 2 and mode 3. Mode 2 and 3 are not used much, okay. Mode 0 is also not used. And then mode 1 you have a 8-bit data, 1 stop bit and 1 start bit, okay. So this mode is mostly used, okay. And then serial in mode 0 only RxD pin is used both for receiving and transmitting. TXD pin will be outputting the clock, okay. So this is not much used. Mode 1 is used, okay. So in mode 1 you have 10 bits transmitted for 1 byte of data, okay. And there will be a start bit which will be always be low, okay, 0. And then 8 data bits, LSB will come first, okay. First you will write the LSB and then finally you will have a stop bit which is always 1, okay. So start bit is 0, in between you have the data bits, and then you will have the stop bit after the MSB, okay. So this is how, okay, as shown in the diagram, this receiver will receive this. So your start bit is always 0, and then you will have your data bits and your stop bit will be 1, okay. This will be coming and it will be put in the S buffer. Similarly, while transmitting also, this data will be put in the S buffer and from there it will be transmitted, okay. And this ninth bit will be going to RB8 and TB8 while transmitting and receiving, okay. Mode 2 and mode 3 we need not what is it, need not spend time. And then yeah, as I told you, this bit 9 will be coming to TB8 while transmitting, and while receiving it will come to RB8 of the SCON register, okay. And then REN is one of the bits of SCON register, receive enable. It will be high to receive data and also for transmitting data. And then transmit interrupt flag, when 8051 finishes one byte of data transfer, it will be high. Similarly, when it receives 1 byte of data, this will be high, okay. So these two are the flags. So we'll be checking the flags, TI flag and RI flag, for seeing whether we have finished the transmission. Okay, maybe receiving or transmitting. Okay, now how to program this, how to write a program for the serial transmitter. So we are using the timer for generating the baud rate. Okay, so the timer has should also be involved in this. So the timer mode register is loaded with value 20. Okay, you can follow this procedure 20, indicating that we are using timer 1 in mode 2. Okay, so mode 2 is auto reload mode, so the pulse will be generated again and again, so you will get a pulse train. Okay, a clock for the baud rate. So timer 1, okay, use timer 1 and then in mode 2, and then th1 is loaded with the value to set the baud rate. Okay, so as told already, if it is 9600, you have to load -3 or fd. Okay, -3 is nothing but fd in h. Similarly, for every value, every baud rate, there is a number count has to be loaded into this. Okay, so according to what is asked to you, you have to uh, put that count into this. And then SCON register is loaded with the value 50H, indicating it is in serial mode 1. Okay, mode 1 is used default, where okay, mode 1, and then you are enabling this REN also. Okay, so it is 0101, which will be the word, control word for your serial communication control register. And then you start your timer. So for starting the timer, you have to put TR1 should be made 1. Okay, set this bit. Okay, uh, timer run bit to 1 to start the timer, and then clear your transmit interrupt flag. Okay, of the serial what is it, serial control register. And then that byte has to, which has to be transmitted, should be put into the SBUF register. And then when TI flag is high, okay, you have to stop it. Okay, otherwise if there is more data, you have to repeat it. Okay, so for the next byte, you have to go to step number 5 and repeat it. So this is how you will program it. Now we'll see some few examples. Okay, so write a program for 8051 to transfer a letter A serially at 4800 baud continuously. So A has to be transmitted again and again serially. Okay, so now as told in the procedure, you use the timer. Okay, timer 1 in mode 2. So the control word is tmod is equal to #20h. Okay, and then to the timer register, you load a count value. So for 4800, the count is -6. Okay, it is there in the initial slides. Okay, so -6 is loaded into the timer count register to the TH register. It is in auto reload. So you will load only the timer higher order register. And then this serial control register is loaded with 50H for what is it, mode 1 of serial communication. And then set the timer. Okay, start the timer. So set B TR1 for starting the timer. And now A has to be transmitted. So move A to the SBUF register. Now the transmission has started. Now if the transmission is over, your transmitter interrupt flag will be set high by 8051. Okay, so wait here. Okay, wait here. So jump if not no byte. Okay, not bit. Okay, so if the jump, wait here. Okay, wait here until this becomes high. When this becomes high, it will come out of this, otherwise it will be here in the same line. Okay, so jump if no bit TI. So TI is checked until it becomes high. Once it becomes high, you come here and clear it and then do it again. Okay, because AA has to be sent out continuously. Okay, so yes, jump to again. So this is a very simple program to transfer A. So the procedure is the timer should be initialized to mode 2, and then give the count for the baud rate, and then SCON register is 50H, and then set your timer or start your timer, and then move the data to the SBUF register and check whether the flag becomes high for the serial communication. Okay, now here is few more characters are being transferred. So write a program for 8051 to transfer yes, okay, 3 characters serially at 9600 baud rate 8-bit data once double. Do this continuously. So the same initialization, what is it, except that your timer count is -3 because the baud rate is 9600. Okay, double that, so you, it is instead of -6 it is -3, and then other things are same. And now in transmission, first load y into accumulator and then call transmission routine. So where the value in A is moved to the S buffer, jump of no byte. Okay, you are checking for the transmit interrupt flag and you are there, and then you are clearing it and returning. So you will return here. Okay, so now move the next character E to A and then again call transmission. So trans. Okay, so here it is again transmitted to the S buffer, and now again the last character. Okay, and then jump again. So do this, repeat this again and again. So yes is transmitted to some output device, maybe a LCD display or something. Okay, okay, so this is one program. And now to receive a data, what you have to do is, instead of checking your, what is it, TI register, you have to check your RI register. So RI is checked. Okay, RI is checked continuously, and once it is cleared. Okay, so now yeah, write a program to receive bytes of data serially, put them in port 1, set the baud rate to this. Okay, so now here you are receiving data to the SBUF register. Okay, from receive data serially and put it in port 1. Okay, so the initialization are the same. Okay, timer control register, and then timer count, and then SCON, and then set timer. Okay, start timer. And now you are transmitting, so you are checking whether the receiver is high. Okay, so receiver interrupt flag is high. If it is high, from S buffer you take it to the accumulator, and from accumulator you are taking it to the port. Now clear RI and jump this. Okay, jump to here. So again and again it is taking data from, receiving data from um, yeah, it is receiving data serially from some other device. Okay, yeah, there is one more point here, that is PCON register. Okay, it's the power control register. That there is one, what is it, bit, the MSB bit is called a serial mode. So this will be, can be used to increase the data transfer rate. So if this smart bit of PCON register, okay, PCON register initially we have studied. So if what is it, to increase the baud rate, okay, how will you increase the baud rate, data transfer rate? So you can use a higher frequency crystal, or you can change the MSB bit of PCON register. So now if this bit is 1, okay, what happens is the division rate is 16. Okay, that is from this divided by 12, no, in usually it is 32. Okay, so now if I want to divide it by 16 to get a higher frequency, double the frequency, this bit has to be 1. Otherwise if it is 0, it will be internally divided by 32 to give 28.8 kilohertz. Otherwise it will be 57.6 kilohertz. Okay, so this is one way of increasing it. So you will have double the baud rate for the same time count. Okay, instead of 9600 it will become 19200. Instead of 4800 it will become 9600, and so on. Okay, you can double it. Okay, and here is the last program. Here what they are telling is, you have to first display a message, we are ready, to the PC serially. You have to transmit a message, we are ready, to the PC serially. Okay, and then receive data from port 1, receive any data sent by PC and put it in LEDs. Okay, and then get the data from port 2 and send it to PC serially. Okay, so get data from PC, put it on P1, and then get data from switches in P2 and send it to AC serially. So port 1 is an output port, port 2 is an input port. Okay, so now here uh, first work is to display we are ready. So you are having the same. Okay, port 2 is an input port, so you are sending ff to this input port. Can be configured as an input port by sending 1 to it initially. Okay, so ff is sent to this, and then these are the usual things. Okay, 20 to tmod, and then fa for 4600 baud rate to this, and then scon 50, and then set beat tr1, start the timer, and then you are taking the data using dptr in, okay, indirect addressing mode, and then you are clearing a move the first character, okay, from the location to accumulator, and then if the okay, here you are having the data we are ready and the last data is 0. So if the data is not 0, you call send. So what is send? Send is just move the character to the s buffer, and then check for your transmit flag, and then clear transmit flag, and this. So this, all these characters we are ready will be taken from using the dptr one after the increment the dptr. Okay, so we are ready, the whole thing will be transmitted first. Okay, and then um, read data from p2. Okay, so read data from p2 to the accumulator, and then you send it to uh, send it to send. Okay, so send it to serially to the buffer, and then you receive the serial data from the switches, and then again move it to port 1. Okay, so you get the data from pc, read data from p2, which is the switches, and then send it to s buffer, and then get the serial data and display it on the leds. Okay, so again jump here, so you are doing it again and again. Okay, so send this receiving, you are checking your ri. Okay, for transmitting you are checking your ti. Okay, receive, and then received data will be there in SPUF. It has to be transmitted to accumulator and then clear. Here is the thing. So receive is this small routine, send is this small routine, receive is this small routine, and here you are reading from port 2 and sending to port 1. Okay, and here you are taking the data from my data from RAM, from the internal RAM. Okay, db is defined by internal RAM, and you are taking every character and displaying or sending it to the PC. Okay, so that's all. Very simple only. Okay, so please go through this. Okay, all the best. Where is it?